All right. Back in the previous chapter, for example, we looked at graphing the linear inequalities, where we just graph the line and we shade either above the line or below the line, right? Let's take a look at let's look at graphing systems of linear inequalities. Let's look at graphing systems of linear inequalities. Alright, so we're talking about the four comparison symbols we have again, right? Greater than, less than, greater than or equal to, less than or equal to, right? And recall when we use dotted lines or dash lines and solid lines, right? So we've seen that already, right? Let's look at system means what? We'll get two or more lines to graph, and basically the idea is to look at the common area that satisfies both of the inequalities. Let's start with a real simple one. Here's what I mean by that. Let's go ahead and graph the following system of inequalities. Let's graph something like x greater than 1. Right, that's a vertical line, right? We see the x in a number, right? And a horizontal line, y less than negative 2. All right. So vertical line, horizontal line. Let's see what the graph looks like here. Alright, so here's y, here's x, and we've graphed these lines before in the past, so not too bad. 1, 2, 3, 1, 2, 3, 1, 2, 1, 2, 3. Alright, so let's graph the first line. Vertical line, x and x greater than 1, right? That means what? We go to 1 on the x-axis and make a vertical line, except it's going to be what? It's going to be a dashed line. There's no equal sign here. Both lines are dashed, right? So it's going to be a dash vertical line or dotted vertical line. Alright, and then now don't shade yet. Normally we would shade what? Greater means shade to the right. Just make a note that we want to be to the right of this line. So right. Okay, we want to be to the right of this line. Now, because it's greater than. What about y less than negative 2? Well, that's a horizontal line. We go to negative 2 on the y-axis. If you recall, again, it's going to be a dashed line. So dash line, make a dash line right there. Alright, so this will be y and y equal to negative 2 essentially, right, on the horizontal line. But we want to be less than that, so we want to be what, above or below? Well, less than means what? Below. So we want to be below this line. So we want to be to the right of the vertical, below the horizontal. So what is the common area? Well, let's see. This common area is going to be down here. Can we see that? Down here, we're to the right of the vertical and below the what? The horizontal. So you want to shade in this area down here. So ignore the shade down here and ignore the other four quadrants, if you will, right? So that's the idea. So the idea for system of inequalities is what? Simply shading in the common area that satisfies both these inequalities, right? Because order pairs down here will have x coordinates greater than 1. We'll have y coordinates less than negative 2. Can we see that? Let's go ahead and try another one here. See if we can figure out the common area to shade. Bottom line. Let's go and clear out the screen. Let's take a look at something like this here. What about something like 3x plus 4y greater than 12, all right? And 3x minus 4y is going to be greater than 4. Alright, so again, the key is what? Get them both in mx plus b form. So let's go and do some algebra on that, right? So 3x plus 4y is greater than 12. Let's get that in mx plus b as we've done in the past. Let's move the 3x to the other side there. Minus 3x. So it takes care of that. So 4y is greater than negative 3x plus 12. And dividing by 4, you can see that we get the following inequality: y greater than, we don't switch since we're dividing by positive, but we will switch right here, right? So, and you'll see why in a moment. All right, so we're going to get negative 3/4 x plus what? 3, right? 12 over 4. So there's the first inequality. Let's go ahead and get the second one in mx plus b form. Again, I just work directly off of it if you don't mind, so save me some space on the sketch pad here. So minus 3x on both sides again. That takes care of that. Alright, So we get negative 4y greater than negative 3x plus 4, and we'll divide by negative 4 this time. So we do have to switch the inequality, right? Can we see that? Because we're dividing by a negative number, so switch the inequality from greater than to what? Less than. So this becomes greater than to less than. And again, negative by negative is positive, so that's going to be positive 3/4 x, and then what? Minus 1 for these two numbers. Alright, so we have the second one. Now we're ready to graph these lines and see where the common area of shading is going to be. Okay, so let's go and do that. So there's y, and there's x. Alright, so let's see here. So we have 1, 2, 3, 4. 1, 2, 3, 4, 2, 1, 2, 3, 4. Alright, let's graph the first one here, negative 3/4 x plus 3. Start off at 3 on the y-axis, as we've done in the past, right? Slope is what? Negative 3/4, so we'll go 3 down and 4 to the right. 1, 2, 3, 4 to the right. We get the other x, get the x-intercept in this case, right? Now, solid or dash? Well, no equal sign, so it's going to be what? A dashed line. Sorry, I didn't draw that real well, but it's going to be dashed line. Alright, so dashed line here for the first inequality, they're both dashed lines, like the earlier example, right? Okay then, excuse me. Now, do we want to be above this diagonal or below it? Well, again, from previous homework, right? Greater than means, well, you want to be above it. But again, don't shade yet, because we need to shade in the common area, right? So I want to be above this line. Above. Now, let's look at this line. Negative 1 we'll start off at. Alright, the y-axis. Slope is 3/4. Again, we'll go 3 up, 1, 2, 3, and 4 to the right. So we end up right here. Okay? So 1, 2, 3, 4 to the right. Right? So again, dash line. So make a dash line right there. Alright? And again, for this diagonal line, what do we want? We want to be above or below? Well, less, that means what? Below. Now, as you can see, the common area is right here. Can we see that? Because this is what? Below the top line and above the bottom line. So we want to shade in this region. Alright? So not too hard at all. As you can see, you just figure out the common area of shading, and then that's basically it. Alright? Let's go ahead and try another one here then. Let's take a look at this problem then. I'm going to clear out the screen. Let's go ahead and graph the following inequality here. What about x less than or equal to 2 and 3x plus 2y is going to be greater than 4. Alright, again, let's look at the graphs of these lines again. Since I showed you the algebra already, I'm just going to solve it in my head here. You should get, when you do that, subtract 3x divided by 2, you should get y greater than negative 3 halves. Negative 3 halves what? X. And 4 divided by 2 is going to be what? Positive 2. Okay? So hopefully you get that result there. Okay? So negative 3 halves x plus 2. That's a 2 right there. Sorry about that. Alright? And again, what's that? That's a what? X in a number. That's a vertical line. Alright? So let's take a look at the common area of shading in that situation. Alright? So let's see here. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3. 1, 2, 3, 4. Alright, so again, vertical line, right? We go to 2 on the x-axis, and this time what? Equal sign, right? So it does have to be what? A solidly drawn line, no dash, right? Solid line. Right? Now, do I want to be to the left or to the right? Well, less than means to the left. So make a note. I want to be to the left of this line, of this vertical line. Right? What about the second line? Well, negative 3 halves x plus 2. Go to 2. Alright? On the y-axis and go what? 3 down, 2 to the right. 1, 2, 3. 1, 2, 3. 2 to the right. We end up right here. Again, it's going to be what? Well, no equal sign, so what? Dash line. Sorry, kind of hard to graph on the sketch pad here. Do the best I can. Dash line, no bottom line's got to be dash. Vertical line's got to be solid. Okay? Again, what about this diagonal? Above or below? Well, greater than means what? Above it. So above the line. Okay then. So we want to be to the left of the vertical and above this diagonal. So clearly, this is the pocket you want to shade in. Right, so not too hard, as you can see. These problems are fairly simple here. Let's just do one more, and then we'll just wrap it up here. Let's go and try this one here. Okay, let's take a look at something like x plus y greater than or equal to, let's make it equal to 5. Alright, and 3x plus 3y less than or equal to 6. Okay, let's go and try this system of inequalities here. Right? Again, let's get them at mx plus b. Just subtract x to do that for the first one. So y is going to be greater than or equal to negative x plus 5. Pretty simple there. Here, a little bit more tricky, but subtract 3x divided by 3, you should get y less than or equal to what? Negative x plus what? 2 this time, right? Because 6 over 3 is going to be 2. That's a 2 again. Sorry about that. All right. So hopefully you can come up with these mx plus b's without too much difficulty upon doing some algebra on them. All right. But anyways, let's see what the sketch should look like here. So again, let's go ahead and draw that. So here's y, and here's x. All right. So let's see. 1, 2, 3, 4, 5. 1, 2, 3. 1, 2, 3. 1, 2, and 3. All right. So let's graph. Let's start the top line here. Start at 5 on the y-axis. Okay. Slope is negative 1. Excuse me. So we go 1 up. I'm sorry, 1 down. I should say 1 down, and 1 to the right. Okay. So again, that's going to be what? Solid or dashed? Well, they're both solid lines. In fact, they're parallel lines. You can see, right? The slopes are the same, right? We call that. All right. So I'll start at 2 here. Again, 1 down, 1 to the right. Slopes, same slope. Lines are parallel. As you solid line, parallel lines. All right. But again, going back to the first line, I want to be above the first line though. So above. All right. Greater than, right? But the second line is down here. You want to be less than, so below the second line. Well, as you can see, to be above this line, below this line is impossible because they have nothing in common. You cannot be above this line, below this line at the same time. So they have nothing in common here, so therefore there's no solution. Now the way to write that for the system of inequalities will be the what? Empty set. Right? Will be the empty set. Okay, so it's going to be the empty set, no solution, because we cannot be above this diagonal and be below this diagonal at the same time. Not possible. Now, if I change the inequalities around, notice that there could be a solution. Just because they're parallel doesn't mean there's no solution, right? Let me just change the inequality around. Let's do one very similar to this right here. Let's try this one here. Let's take a look at x plus y. Let me change it. X plus y less than or equal to, make it less than or equal to this time, 5. And 3x plus 3y will be greater than or equal to 6 this time. So let me change the inequalities around. Again, it's the same deal, right? You're going to get y except the inequality change, but the same mx plus b forms, right? Less than or equal to negative x plus 5, all right? And y less than or, this will be greater than or equal to, sorry about that, you cross it out, y greater than or equal to, right, negative x plus 2. Okay, so the inequalities change, but the mx plus b form stay the same because this is basically the same problem, right? So, but again, let's take a look at the graph this time. Let me try to see if I can squeeze it in here, since I'm running out of space here. All right, so let's see here. 1, 2, 3, 4, 5. 1, 2, 3. 1, 2, 1, 2, 3. All right. So, anyways, let's look at the graph. The first line again, same graph, same lines, right? So, start at 5. 1 down, 1 to the right. Alright, so again, both are solid lines once again. Alright, except this time we want to be less than, so we want to be what? Not above like here, but below this time. Below this line. How about the second line? Well, start at 2 again, lines are parallel, 1 down, 1 to the right. Except it's greater than, so you want to be what? Above this time. So now they do have something in common. Below this line and above this line will be what's in the middle. So we shade in the middle in this case. Alright? So just because they're parallel doesn't mean there's no solution. In this case there are solutions right in the middle here between the two parallel lines. Okay, so let's go. Key idea again is going to be what? Graph the lines and see where the common area of shading is going to be. In this case, it's right in the middle here. In this case, they have nothing in common, so empty set, no solution. Alright, so get some more practice on these concepts. No Blackboard postings for this particular section. So take care and have a great day.